Hello, and welcome to Math with Asna. In this lesson, we are going to talk about triangle congruence using SSS and SAS. We are going to discuss these two shortcuts for proofs that involve triangles. We'll talk about why they work, and then we'll practice some proofs. SSS and SAS are shortcuts to prove that triangles are congruent. SSS stands for side, 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 and SAS stands for side, angle, side. And what this says is if you have two triangles such that there are three pairs of congruent sides, then the triangles are congruent. So I'm going to draw two triangles here. And this says if three sides are congruent, then the triangles are congruent. Previously, when we try to prove that triangles are congruent, we had to prove three sets of congruent sides and three sets of congruent angles. But this is a shortcut where if you just prove three sides, you can immediately jump to saying that the triangles are congruent. You don't even need to address the angles at all. The next one, SAS, says if two sides and the included angle are congruent, then the triangles are congruent. Let's draw that out. Two sides and the included angle. The included angle is the side or the angle that's formed by those two sides. If I were to trace these two sides that have the tick marks, these are the included angles. They're right in the middle of that angle and that angle. So side, angle, side, two sides and the included angle. You would not need to do anything with that third side, and you wouldn't need to do anything with those two other angles. You could just immediately say, this means that the triangles are congruent. Let's take a minute and quickly discuss why this even works. SSS says that if two triangles have the same sides, then those triangles are congruent. Let's say that these triangles are congruent. That means that the side lengths are fixed, right? This could be 4, 3, and 5, for example. And I would have to have the same side lengths here. The only way to have two triangles with the exact same side lengths is if it's the same triangle. It's just transformed in some way. It's flipped over, it's shifted around, it's turned upside down, but it's essentially the same triangle. They have to be congruent. Once I take a point from this triangle and move it to change the angle, I have immediately changed the sides. So I can take this triangle, and right now it's congruent, but if I try to change it so that the angles change but not the sides, it's not possible. The second I change the angle measures here, the side lengths will also change. So I don't need to do anything with angles if I'm using side, side, side. If the sides are congruent, the whole thing is congruent. For side, angle, side, if I have two triangles, and I'm going to say that they're congruent, and they're congruent by SAS, I want you to think about this side right here. That's across from that angle. Can you change this triangle so that this side length is different, but everything else stays the same? If I try to move this triangle so that the other two sides and that angle stay the same, but the third side changes, the moment I move that side to make the size different, I've now changed this side and this angle, which means it's no longer congruent. So if you have two triangles that have two sides and the included angle, then immediately you can say that those two triangles are congruent. Let's do an example. I've got two triangles here, and my given is that Q is bisecting AN and DG. I've already put that statement into my chart. I haven't yet put it into my diagram, and that's because I haven't made a congruence statement yet. In my diagram, the only time I'm going to put tick marks in there is if I clearly say this is congruent to this. I haven't said that yet. Now, we always want to start a proof by using our givens. If Q is bisecting AN, what does that mean? That means that AQ and QN are congruent. That is the definition of a bisector. A bisector cuts things in half. We also know that Q is bisecting DG, which means DQ has to be congruent to QG. DQ has to be congruent to QG. And we have the same reason here, definition of a bisector. All right, now so far our two shortcuts for triangles are SSS and SAS. I have two sides, so right now I haven't decided which one I'm going to use. I don't have any more given statements left. Once I run out of given statements, I'm going to move on to my diagram. If I were to do side, 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 I would need to prove that DA is congruent to NG. And I don't see a way to do that. So I'm going to see if I can do SAS. If I wanted to prove that the triangles are congruent by SAS, I would need to prove DQA is congruent to NQG. And I do see that that's possible. These two angles are vertical angles, so I can say that they're congruent. Angle DQA is congruent to angle NQG, and that is because vertical angles are congruent. And I'm going to put my tick marks in. I can clearly see that this is SAS because I have two sides, and the included angle, which means I'm allowed to say that the triangles are congruent. DQA is congruent to GQN, and that is by SAS. Let's try another one. H is the midpoint of RL. MR equals 5. That's 5. TL equals 5. MH is congruent to TH. And I want to prove that the triangles are congruent. Well, I know that I'm going to do either SSS or SAS. I'm not sure which one yet. So let's start with our given statements and see what conclusions we can make. H is the midpoint of RL. If H is the midpoint of RL, that means that it cuts it in half. I can say RH is congruent to HL. That is the definition of a midpoint. That first given statement. My next given statement, I'm going to actually use the next two. MR is 5, TL is 5. I have two lengths that are equal to the same thing. Therefore, they're equal to each other. MR equals TL. That is the transitive property. Now you want to be careful here. To prove that triangles are congruent, I need to prove the sides or angles are congruent. Not that the sides or angles are equal. MR equals TL. This isn't exactly where I want it to be yet. This right now is sitting in algebra world. I need to bring it over to geometry world. And I'm going to do that by using the definition of congruence. So MR is congruent to TL because their lengths are equal. If the lengths are equal, then the sides are congruent. Okay, let's see. I have MH is congruent to TH. I have RH is congruent to HL. I have MR is congruent to TL. So I have three sides that are congruent, which means I'm going to use SSS to prove that the triangles are congruent. Triangle MRH is congruent to triangle TLH. And that is by SSS. So overall, for triangle congruence proofs, you want to make sure that you are proving either three sides congruent or three angles congruent. I said that wrong. You want to prove three sides are congruent or two sides in the included angle, SSS or SAS. And in future videos, we'll talk about other shortcuts. If you learned something, please like and subscribe, and stay tuned for more videos.